All right, recording's re-rolling. All right, one more challenge I was gonna throw in for you guys, so let's go do this. All right, so we're looking at these relativity formulas here, okay? And you guys see the time dilation and length dilation are the same format, or sorry, time dilation, momentum dilation. I meant to say these are the same format, okay? And the graph looks like this. Okay? So if you are at zero speed, you're at zero momentum. That would okay. There'll also be like zero time difference. And the faster you go, the more you're going to, the more dilation that happens. Okay? But what about this length dilation? Like, what if you made a graph out of this one? What would this graph look like? Okay? So let me throw this up here so you guys can focus on that. Okay? Think about it. What's that going to look like? Let's get some axes going. Okay? This is like that question with Earth twin and rocket twin, and Earth twin takes out his telescope and is looking at rocket twin ship. Says, "Whoa, what happened to your ship? It's so short now." So we're going to put speed in meters per second on this axis. We're going to put length in meters on this axis. Okay. So I'll give you guys a hint. Okay. If the rocket's not moving at all, if it's zero speed, then everybody agrees how long the rocket is, right? So rocket's on Earth, everybody's at rest, both twins are side by side, they both pull out their meter sticks and say, yep, the rocket is as long as it is. Now, on my paper, it was 8 meters. For you guys, it was probably something else. Okay. Can you guys figure out what the rest of that graph would look like based on this right here? Oh, this. What's the limiting speed in the universe? Speed of light. I should throw a C there, right? Like on this momentum graph, I know that turned into a vertical asymptote. But what about this one? Huh? If what if you do approach the speed of light? Guys, what is c squared over c squared? What's 1 minus 1? What's the square root of 0? What's 0 times anything? 0. So on the C, with this, what would be happening at C? It would be 0, wouldn't it? It'd be 0 length. Okay. That kind of matches up with the story. So we got 2 points on the graph, right? That kind of matches up the story where like the ship was 8 meters long. Earth twin looks through the telescope and says, no, it's only like 3 meters long, right? It's like the length is going down, isn't it? Right? Ooh, a square root. There's a negative in there, so it makes like a backwards, like it would call like a horizontal reflection, I think, something like that. Okay. Ooh, how many of you guys think this is going to follow like a square root curve? Is going to do something kind of like this? You guys think that? Right? Yeah, that's what that would look like. Right? And then, okay, so to go from 8 meters down to 3 meters, you'd have to go insanely fast, like really close to speed of light, which was what my paper was showing. So my numbers were something like that. Okay. This is, I think I may have mentioned yesterday, the fact that photons move at the speed of light, or anything that's massless moves at the speed of light, like has to. There's a case to be made that space and time don't even exist from a photon's point of view because everything just contracts down to 0. So yeah, it's an interesting idea. All right. And that is oh, yep, that's a wrap right there.